Hello and welcome to this video. My name is Girish, and in this video I will explain to you about disk scheduling algorithms and how to solve them. Do note that I will be explaining how to solve these algorithms in a question based point of view while solving the examples for you to better understand. Without further ado, let's get into the algorithms. There are basically 6 disk scheduling algorithms, which are namely first come first serve, shortest seek time first, scan, look, and circular look. Before getting into how to solve these algorithms, I'll first give you an idea about what will be given in the questions and the first 2 steps to solve every algorithm, which is common in all the algorithms. So, in every question which we will get regarding disk scheduling algorithms, we will be getting the number of requests in an order, the current position of the read/write head, and the direction of movement. For the first 2 algorithms, the direction of movement will not be applicable. So I'll explain what the direction of movement is when we get to scan and the other algorithms. And now I will explain how to solve the first come first serve algorithm, while also telling you what the first 2 common steps to all the algorithms are. In first come first serve, as the name suggests, we will move the head towards whichever request arrives first. So to explain, I'll take an example in which the order of requests are 2, 170, 43, 140, 24, 16, and 190. And the current position of the read/write head is 50. So now the first step, which is common for all the algorithms, is to put all these requests in a number line in ascending order. And so we'll put all those requests in the number line in ascending order, and I've done that as you can see in the screen. And when it comes to first come first serve, we're going to be moving towards the request which comes first. So from 50, which is our current position, we'll move to 2, and from 2 to 170, 170 to 43, 43 to 140, 140 to 24, 24 to 16, and 16 to 190. Now that we have mapped the head movement, it's time for us to find the total head movement, which is the objective of every algorithm. The total head movement is calculated by adding the total number of movements of the head, and to find out how much the head has moved from one request to another, we'll have to subtract one request from the other. Basically, the higher request is subtracted by the lower request. For example, to find how much the head has moved when it has moved from 50 to 2, we subtract 50 and 2, so we get 48. And so we find out all of the movements similarly, and here is the total head movement of the given problem. And that is how we solve first come first serve. The total head movement is the solution for the first come first serve algorithm. Next, we move on to shortest seek time first algorithm. In shortest seek time first, we do not look at the order in which the requests have arrived. Rather, we look at which request is nearest to the current head position. So if I take the same example, I start at the position of 50, and the nearest point to 50 is either 43 or 140. Between these two, 43 is obviously the nearest position, and so my head moves from 50 to 43. And we continue to do this for every single position the head moves to. Here is the mapping of the head movement when it comes to shortest seek time first algorithm. After mapping, we have to find out the total head movement using the same process as we did before. And when we use the process, this is the total head movement when it comes to shortest seek time first algorithm. And thus we have solved first come first serve and shortest seek time first algorithms. Next, we will move on to scan, cscan, look, and clook algorithms. In scan and look algorithms, the direction of movement comes into play. The direction of movement is the direction in which we should move our head until we reach the end. So in scan algorithm, which is also known as elevator algorithm, when we start from 50 and let us suppose the direction of movement is left, I will go from 50 all the way to 0 while satisfying all the requests in the way, which are 43, 24, 16 and 2. When it reaches 0, the direction of movement reverses and changes to right. While going towards the other end, which is 199, I will not satisfy 2, 16, 24 and 43 because they have already been satisfied, and rather I will satisfy 140, 170 and 190. And it will not reach the other end 199, and rather it will stop at 190 itself. And like previous algorithms, we find the total head movement, which is displayed in the screen right now. And thus we have solved the scan algorithm. Next, we have the C-scan algorithm. The C-scan algorithm is similar to the scan algorithm, except when it reaches an end, it goes directly to the other end, but it does not satisfy requests while going to the other end. So when I start from 50, I'll go from 50 to 0 while satisfying 43, 24, 16 and 2. But now it will go from 0 directly to 199 without satisfying 140, 170 and 190. After reaching 199, it will then start moving towards left again, and then it will satisfy 190, 170 and 140 respectively. And thus it will give us this mapping and this head movement. And finally, we have the look algorithm. The look algorithm is exactly the same as the scan algorithm, except it does not reaches the ends of the number line. So we have 50. It starts from 50 and moves to 2 while satisfying 43, 24 and 16, but it does not reach 0, and then it reverses the direction and satisfies 140, 170 and 190, which gives us this mapping as shown in the screen, and it will give us this total head movement. So C-look is also very similar, where it's the exact same thing except it does not go to the ends. So over here in C-look we have 50 to 2 satisfying 43, 24 and 16, and it moves from 2 directly to 190 without satisfying any of the requests in between, and then it moves from 190 to 140 while satisfying 170, which gives us this mapping as it is now shown in the screen and gives us this total head movement. With this, we have completed all the algorithms for disk scheduling. Thanks for watching this video, and I hope you have a great day.